Good morning, everyone. Good afternoon and good evening. Welcome to the fourth Maritime Ammonia Insights webinar with the Ammonia Energy Association. My name is Sofia Fürstenberg Stott, and I am your host for this session today, where we will meet Jan Flores, Vice President from NETSco, and Edward Schwarz, Vice President of Sales Marine Systems with ABB. And we will learn about the synergies of using maritime ammonia on inland waterways in the US. But before I welcome them on board, I will first mention that this session will be recorded. The recording will be available on our website. The slides will also be available there. And as soon as we manage, a written summary of this webinar will also be posted in due time. So for those of you who may not be too familiar with the Ammonia Energy Association, this is a global non-profit industry association that promotes the responsible use of ammonia in a sustainable energy economy. And so we encompass both the ammonia for existing applications, the decarbonization of ammonia in existing applications, as well as the adoption of low carbon ammonia in new applications. And that include the use as a fuel for electric power generation or maritime transport, and indirect use as a hydrogen carrier and carbon-free energy commodities. So we initially started back in 2004, and today we count the membership up to 185? No, I'm not sure. So as maritime directors, I am one of them. My partner Connor is the other one, and we help each other running these webinars. And we do not do only that, but our purpose in this association is help to bring the maritime insight, the maritime needs for progressing ammonia as a maritime fuel out to the wider ammonia stakeholder environment. So that's what we are here to do. And so this is the fourth of our Ammonia Insight webinars, Maritime Insight webinars. And so we have the luxury of handpicking select projects where we think there is a great learning opportunity for the audience out there. And we are here to kind of raise the level of understanding and connecting the stakeholder environment. And so already now I can tell you that on the 17th of August, we will have our fifth webinar where we have invited the big engine maker, MAN Energy Solutions, together with Maritime and Port Authority of Singapore to talk about some of the key engine development projects taking place right now. So here we are. So the subject of today's webinar is to discuss and explore the opportunity of ammonia as a fuel along the US inland waterways. And so we would like to kind of understand the business synergies there are around the production, the transport and use of ammonia in that specific region. And we will also learn about the specific application of the electrification of a towing boat. So without further ado, I would like to invite Jan Flores from NETSco to the stage, and he will help us set the scene for these ammonia synergies, looking at the statistics of US inland waterways, the regulations we have over there, the supply infrastructure of ammonia, and not least sharing with us a recent application for this shipping project. Jan, please.
Thank you, Sofia. I think, I don't know if I don't see the presentation. Well, I do see it now. So thank you, Julian. You can actually you can jump to the next slide altogether. So again, thanks for the Ammonia Energy Association for inviting us. NETSco, it's a naval architecture firm. We've been in business for over 37 years now. And we have been involved in ammonia for many years. In fact, some of the inland ammonia barges that dated before NETSco was in business were designed by the founders of NETSco. They used to work for another company that actually designed some of these barges that are over 40 years old. Interestingly enough, Ammonia Energy started more as from the hydrogen side. We were hired by a cruise ship company to do a fuel cell project. It was more of a study, right? The fuel cell with hydrogen. And that's when quickly we realized that storing hydrogen was very difficult. And that's when we found ammonia to be a very efficient hydrogen carrier. And that's how this evolved. Then, unfortunately, cruise ships are now having some other problems with the COVID and all that. So that project was put on hold. But anyway, I think as Sofia said, we're going to talk more here about the opportunities and where we see ammonia fitting the bill in the inland waterways. On the agenda, as you see, the first thing we're going to talk about is the actual statistics. We're going to talk about the magnitude of inland waterways and waterborne transportation. Then we're going to talk about the actual emissions regulations, because that is the driver, right? So it's I recently had to buy a car, and then I was looking into electric cars, obviously, and then there were some things that I had to consider, and one of them was price. So if there's not another force pushing me into buying the electric car, I probably would have not done it, right? So, and then we're going to talk about the actual ammonia supply infrastructure in the inland waterways, which is actually that's one of the biggest opportunities. And then we're going to get into a little bit more into the details of some of the applications and what ammonia as a hydrogen carrier, and where we see the benefits of using ammonia as fuel in the inland waterways, or let's call it the inland towboats. So you can go to the next slide, please. So for our American audience and folks in the industry, they've probably seen this slide before. This is from the American Waterway Operators, which actually highlights the efficiency of waterborne transportation. I think they had the metric comes from them, but I converted it into ton-mile per gallon, right? So that we have some sort of reference of how efficient transporting via waterways is. And as you can see, this is the figures I have of 578 million tons a year came from one source, but I heard somewhere in the order of 700 million tons of cargo in the inland waterways. And when we compare marine transportation to over-the-road transportation, as we can see, we can move a lot more cargo for a lot less fuel. So it's very efficient, right? So we've already contributing to the emissions reduction just by going into the marine transportation. At the same time, of course, there's a lot of vessels in the inland waterways. This figure I have here of 5,500 towboats and tugboats, it includes them all. I don't have the breakdown, but I think, and probably Ed can talk more about that on his presentation, but I'm thinking it's about 80% of that. So that's a lot of boats. And this figure also, I think, comes from the American Waterways. We emit in the inland waterways 6.2 million tons of CO2. So even though it's a very efficient means of transportation, by the potential of reduction of this is CO2, but in greenhouse gases in general is very large. We can move to the next slide, please. Okay, so as I said before, I mean, the regulation is a huge driver in environmental compliance. The reason is because even though some environmental compliance initiatives eventually turn out to be very cost effective, the cost of entry is always high. So there always has to be some incentive, and of course regulation in the maritime industry is usually the driver. And I want to talk a little bit about how this applies to the inland waterways, because it is very specific. As of 2 weeks ago, and this is anybody seen the news, they know there was some ruling against the EPA and their jurisdictions. But for now, our understanding is the EPA sets the standards and the regulations for emissions in the marine world. For most of the time, I'm sorry, let me back up a little bit. So when MARPOL, on the international, obviously MARPOL is a convention within IMO that regulates environmental compliance. In this case, MARPOL Annex 6 is the one that regulates emissions. But MARPOL, unfortunately, don't apply to the towboats, because towboats don't have international documents, right? They're regulated by the state and the federal regulations within the U.S. So even though often MARPOL does align with EPA, for example, EPA Tier 3, Tier 4 values are very close to IMO Tier 3 values, and the dates are coincide with each other. MARPOL is not applicable on this vessel. So how emissions regulations then is enforced in inland waterways? So if we go back to early 2000s, we saw how the over-the-road regulations that EPA created for vehicles, those eventually trickle into the marine world. EPA Tier 2 back in 2007, then EPA Tier 3 and EPA Tier 4, those all came from over the road. And then there were some pressure to roll those into the marine world, and that's how this came about. So now, if you do a new installation or new engine on a towboat vessel, and the engine is over 800 horsepower, you have to meet EPA Tier 4, which is a pretty stringent regulation, but it only controls NOx, right? NOx and SOx. So as of today, there is no greenhouse gases regulations that will in place for the inland waterways. So what we think is going to happen, and we're just going to follow the history of how over-the-road regulations translated into marine regulations, is on August of last year, EPA announced their I believe it's the Clean Shipping Act of 2022, right? So, sorry, disregard what I said. I'm sorry. On August 2022, EPA announced some of the over-the-road requirements for up to 2050, or their goals, I should say. And then they stated that those are going to start coming in on independent, phase regulations. For example, there's one that was finalized in December 2021, which actually has some greenhouse gases reduction requirements for vehicles that are going to be going to market on 2026. So what we believe is going to happen is, once those regulations start coming into play for over the road, then they're going to trickle into the marine side. And eventually, I mean, if we follow what's been proposed here, by 2050, anything coming new should be zero emissions, right? So that's what the current regulation states, or the current forecast, I should say, or target states. So let's go to the next slide, because I think I'm running a little out of time here. So I'm going to jump this one really quick. So basically, here, this is where the potential, and this is why we're talking about ammonia, is there's a lot of ammonia in the U.S. Midwest, a lot of production of ammonia and a lot of transportation infrastructure. Everything that you see in the mustard-looking color that says nitrogen is really, I mean, it's ammonia, and there is a lot of production in Louisiana. Donaldsonville, CF has a huge plant there, and there's some other plants throughout the waterways, or should I say throughout the Midwest. And then that purple line that you see there, that's actually an ammonia pipeline. So you see there's a pretty robust distribution network already. And of course, the blue line, those are the inland waterways. And as you know, there is currently a lot of movement of ammonia within the waterways. So this is why we see ammonia as that has a potential on the inland waterways, right? So if you move to the next slide, this is where we actually try to understand why we're looking at ammonia and what is the problem of ammonia, right? So if we look at the one highlighted in yellow, that means that's your energy density, volumetric energy density. So as you can see, MgO is 3 times more, has 3 times more energy per unit volume than ammonia. But at the same time, when we looked at the carbon fuel coefficient, right, we see an actual pretty drastic change from nothing to 3.2. That's I believe that's a ton of CO2 per gallon of fuel. So it's a metric, but I think what's important here to see is that, yeah, ammonia is carbon free, and MgO is actually the highest, has the highest carbon fuel coefficient. So how do we get from getting over the hurdle of energy density so that we can get some greenhouses reduction, right? That is the $64,000 question. So we can go to the next slide, please. This one, very quick. This is just a little bit of the metrics of using ammonia as a hydrogen carrier. But in the interest of time, I'm just not going to cover this too much. But it basically, as we can see, you can pack a lot more hydrogen in ammonia as you can in hydrogen itself. And as we further talk about hydrogen in the context of this presentation, we're always going to talk about it from the point of being stored as ammonia, right? So let's move to the next slide, please. All right, so talking about the towboat here in the Mississippi River, which again, as I said before, there's like 5,000 towboats in the Mississippi River. They have a very efficient propulsion train system, which is traditionally either for the larger towboats, it's a medium speed. For the smaller towboats, it's a higher speed diesel engine. And by the way, as far as I know, everything in the river uses low sulfur diesel because of EPA requirements. There are some 2-stroke engines in the river. EMD is a very common. In fact, the picture on the lower right is an EMD, probably a 645, which actually it's a very common engine, 2-stroke, is very robust, and EMD has done a pretty good job in converting these engines to be able to burn LNG. Unfortunately, they don't meet any emission requirements, but if you today in the river, if you have an EMD engine, and I believe is their latest model, the 710, and you want to burn LNG, you can do it. They have 2 ways to do it. One is they call it dynamic blending, which it's like a dual fuel. Basically, you're injecting LNG into the combustion of it, and you with that you reduce the NOx and the SOx of the engine. And if LNG pricing is down, well, you get some benefits there. Then there's another more permanent conversion kit that you can do. But anyway, this is to highlight that, you know, this is a typical arrangement. On the bigger boats, you have 3 engines. The picture above shows the tail shaft arrangement. So you go to a gearbox or reduction gear, tail shaft, fixed pitch propeller. You see that on the river all over the place. There are some companies that started using azimuth drives in the inland waterways, which has shown a lot of benefit for maneuvering and so on. But they still driven by a diesel engine, right? And can we move to the next slide, please? All right, so this is where I think what we came here to talk is, okay, so how do we go from point A to point B, right? So there's 2 ways there are 2 ways to as today to go from diesel fuel to use of ammonia. One is the internal combustion engine route, which, as Sofia mentioned, MAN is going to talk about that in the next webinar. MAN is one of the leaders on 2-stroke ammonia power engines. But one way to do it is injecting ammonia into the diesel feed to the engine. There has been a lot of tests done there. And fair enough, there have been a lot of tests there, but it's not efficient. You create NOx. On lower concentrations, you don't get the benefits of the carbon reductions. On higher concentrations, you start getting NOx, so it's not efficient. The other option is hydrogen into diesel. Again, it's a very complex system to do it. They're doing it right now on power plants, but we see on towboats to be too much complexity, but that's an option. And of course, the other option is the actual internal combustion engine, where Wärtsilä is already announced that they will have a 4-stroke internal combustion engine by 2024, 2025. So that's an option. Now, the other option, which is the one I like the most, but it's obviously the one that's the furthest apart, is the fuel cell route. There are 2 types of fuel cells. One of them is the PEM, which strictly burns hydrogen. So you would have to crack the ammonia. It's actually real, but you would require to change the arrangement of the boat that I showed earlier, of the 2 main engines with the tail shafts and the propellers, and go into a diesel electric plant that would allow you to plug and play the fuel cells and have some battery capacity as well, which Ed's going to talk a little bit more about that on the next presentation. And the one I like the most, but this is the one that is the furthest apart yet, is the solid oxide fuel cell burning ammonia directly. And this one is unfortunately not commercially available yet. There is a vessel in Norway today testing one, which we hope is successful, because the footprint and the simpleness of the installation will make for a viable installation. So I think I have takeaways, but I think in the interest of time, I'm going to skip those. Could you go to the next slide? I just want to make sure I didn't miss anything. No, so these are the takeaways. So we can keep those for the end of the presentation, so that we can go to the Q&As. And again, sorry, I was rushing a little bit, but I want to get into the Q&As, and we can get into a little bit more detail there.
Thank you very much, Jan. That was very informative and a little bit of a lecture in itself. That was great. Thank you so much. I will now invite Ed Schwarz to the stage here. And Edward, when we spoke, I noted down something you said to me that I thought was obviously worthwhile noting down. And you said that the owners have to let go of always comparing ammonia with conventional fuel. And I can see from your presentation also that this is a bit of a story that you are trying to tell here. So Ed, please start.
Wonderful. Thank you, Sofia. Yeah, thanks everybody for dialing in and giving this opportunity to share some information. And yeah, it's an interesting introduction you had there, Sofia, with yeah, one of the challenges we definitely find with owners as they're making this transition is we're always trying to compare it back to what we know of diesel fuel challenges. And I can tell everybody and anyone who's in this call, or we're talking to a lot of early adopters, people doing a lot of research, they realize it's hard. This is not for the faint of heart. This climate change and finding these solutions that are going to be the fuel of the future is a tough endeavor, and only people with the fortitude to overcome the challenges will be able to see their way through it. And you know, it's something we have to do. But yeah, if we certainly always compare it to how simple diesel and how much energy density and how non-lethal diesel fuel is relative to human interaction compared to some of these other alternative fuels, including ammonia. Yeah, you'll be sorely disappointed at every turn in the design, but it's still rewarding and still worthwhile.
Julian,
So,
we can't see the presentation.
if you could, yeah, flip over to my presentation, and I can vamp a little bit more. I give a little bit about myself. So I started my career as an engineer, shipboard engineer. I have a chief engineer unlimited license, and started my career, even though it wasn't very long, at least it doesn't feel very long for me, on steamships mostly. Mostly sailed on steamships because that was what was available, and a lot of the U.S. flag container ships were running steam plants, and that's what I was sailing on mostly, and upgraded my license to a first engineer steam. And now I get to talk about and work on these types of projects. So through a career of starting on heavy bunker fuel to now this transition to ammonia, it's definitely a fun time to be a marine engineer. So very exciting. But yeah, you can flip to the next slide, and I will start right in. Yeah, I'll get to the course and won't bore us too much here. This is the okay, so this shows kind of the transition that we see in this decarbonization. So a lot of people say, like, well, what's the pathway to decarbonization? Everyone's looking for what's the single solution that's going to work for everybody. And what we're finding in the market is really kind of clear about is there's not a single solution that's going to work for everybody. So we're seeing these early adopters already going into energy storage, using batteries as systems. We're seeing that as being a very good solution for vessels that go from point A to point B, that have time to charge, that are in urban areas, that return to the same ports all the time. So kind of the ferry traffic is moving towards this energy storage. We like energy storage. It's a very kind of known commodity. There's already a lot of rules and regulations coming into the maritime industry based on using energy storage or batteries for propulsion. So it's a good for this segment, but obviously it's not going to work for all segments. So that's what we're here to talk about. Is on the inland side, you have towboats that could transit all the way from Minnesota down to New Orleans or to Texas, and obviously they can't charge batteries along the way. So how are they going to work? And now we see this kind of look at all these different types of fuel, whether it be ammonia in this case or methanol. We're seeing methanol sometimes being investigated. Are we doing onboard reforming? Are we going to be looking at generators that are going to be able to run these alternative fuels? Or looking at fuel cells? That's the process that's going on right now within the industry, and that's the investigation. And I'll certainly keep my time brief, but we can get a lot into the different challenges that come with whether we try to use it as a fuel on board or use it as a carrier, ammonia as a carrier for hydrogen, and then do either reforming on board or using a fuel cell. Again, going back to the original comment, there's certainly nothing that will come very easy. They all come with challenges, but But the nice thing about the maritime industry is we're used to that, and we'll find solutions. So it may not be the same solution for all boat types, but we definitely see this green ammonia as part of this transition to eventually getting to carbon-free shipping. I think one of the things that Jan pointed out that's very good is the maritime industry, by its nature and its history, is the greenest form of transportation when compared to rail, road, or air. But as road is electrifying and lowering its footprint, marine also has to keep pace. So right now, I think they say the global marine industry accounts for 3% of the global emissions, which is significant. So as we look to these carbon-free shipping, whether it be 2040, 2050, it's worthwhile, but it's definitely going to be a tough challenge. So you go to the next slide. What do we see as ABB? We're electrical engineering, integration company, systems company. What we're seeing is this progression in electrifying of vessels. So, and this is kind of this is the backbone that allows for this decarbonization. So all the way to the left, you can see is historically diesel mechanical systems. As Jan talked about, you got a gearbox, a propeller, a direct coupled engine, has a lot of advantages. Disadvantages, it's really hard to introduce any of these new technologies with this type of system. So we've seen for a long time, for over 100 years, we've been utilizing diesel electric systems on board vessels. It's certainly nothing new, and it's certainly nothing new to the oil and gas industry, has been utilizing this, kind of creating the power using diesel engines, generating electricity on board and then distributing that electricity to your consumers. Pretty much all cruise ships are built this way. Pretty much almost all the oil and gas service vessels, where you have this kind of varying load situation. So to help improve reliability is number one, and then number two is reduce fuel. But now what we're seeing is we can do even better than that, than diesel electric, is moving to these hybrid systems. So now we have the introduction of energy storage, and we have the introduction of powering from the shore side. So we're seeing this hitting. I think I don't think you can open up a maritime publication without seeing some notice of a new battery operated vessel or some type of low emission hybrid vessel hitting the water. So we're seeing this becoming more and more commercially mature. Like I said earlier, more regulations are being developed around this, so it becomes easier and easier to implement this. Now what we're seeing is the next phase of this development, and that's the integration of these fuel cells into electric systems. So now we're seeing everyone's aware of some of the announcements. Some of these vessels are coming out next year, hopefully, maybe the following year, operation on fuel cells. And it's very interesting, and this is what enables us to utilize ammonia and really reduce emissions. So it's that transition from having these diesel generators on board, generating your power, to using a fuel cell. So this is kind of the progression that we see. It's moving very quickly. This left to right span in the maritime industry used to be very, very slow. It's not a fast trend of technology, but we're seeing the opposite is true. It's actually happening right now very quickly. So it's very exciting times. You go to the next slide. I think I touch on, okay, some of these benefits. I will just go over this briefly. Is once we go to this electric propulsion, it allows for shore power, easier integration of shore power, fuel cells, batteries, electric propulsors, so motors driving propellers, which are more efficient than gearboxes. This is kind of the transition and the benefits that we're seeing that comes with decarbonization. But one of the things to touch upon that's I think very important for the electric is it allows for the future integration. So as we all know, especially on the inland side, and Jan as a designer knows this all too well, and since we're kind of concentrating on US Jones Act vessels, but this is true globally, but I think it's most extreme in the US, is the vessel life is 40, 50 years. So there's going to be a lot of technology progress in the next 50 years. I don't think anyone assumes they're going to be driving this car with the same engine 50 years from now that they could buy today at the dealership. But yet you have to design your vessel today for this long life. So what we're thinking is with an electric system, it allows for integration of higher density energy storage in the future. It allows for the integration of replacing diesel generators with fuel cells in the future, for adding that shore power for cold ironing or charging later, once there's more infrastructure in the ports for shore charging, or shore charging becomes requirements for a lot of green ports. So what we're saying is that the benefits to electric is it really kind of makes the vessel more versatile for retrofitting and for upgrading in the future. Diesel mechanical vessels are very hard to introduce new technology to. So that's kind of one of my takeaways from this. And the next slide. Yeah, I had to talk about ammonia, of course, being the topic. So kind of some of the things that we're learning from some of our friends in the ammonia industry. Everyone's talking, well to wake. Obviously, that's the topic, and the topic is always how green is the fuel. It's a little frustrating, I find, that everybody wants to talk poorly about early adopters who may be moving to, say, using energy storage, but the power plant is not 100% renewable energy today, but maybe the power plant could be a carbon fuel. Typically, it's still more efficient way of getting energy, but it's also going to be moving towards more renewables in the future. So everyone wants to know, yeah, the path towards green ammonia. How do we get these fuels and how do we get them green? So this is some of the information that we've been getting from some of the green ammonia production, and you can see there's challenges. So on the well side, there's certain things that are looking positive. On the distribution side, yes, we have a lot of distribution. Jan touched on that. But yep, storage on board is definitely a challenge, and especially this is comparing it again to what we're used to with diesel fuel. And there's some safety challenges. So there's a lot of challenges there, and that's not dependent on green ammonia. That's just the nature of ammonia. And then in the wake, so in the consumption, so there's a lot of benefits, but there's also some challenges in the design. So we certainly acknowledge the benefits, but we also have to design for the challenges. And then I believe I have one last slide. Yeah, just this up here. Okay, so people might be, it's not an ammonia project, but it is a fuel cell project. It's a methanol towboat that's in the news right now, since we're talking about on the inland side, using fuel cells. And so one of the things that's interesting with this topic and why we're talking, and Sofia and Jan and I were talking earlier about this in preparation, is you have these really large global fleets that typically lead in new technology development. They have the global benefits of working in multinationally. They have big stockholders. They have high profile, and they're usually the ones that kind of introduce new technology because they can. But what we're actually seeing is with a lot of this green technology is reverse. It's short distance shipping that's introducing new technology, which is a first for the industry. And when I look at like towboats like this, how hard it was to get adoption of say like Z drives for safety, and ZF worked very hard in getting Z drives, and now hopefully there'll be L drives in the future. But to see these inland, relatively small on the global scale companies being these first adopters, kind of really learning and developing this new technology that does benefit everybody, including the large companies, because a lot of this is the design that it takes. A lot of this is working with the regulatory groups to get the regulatory groups to document how we're going to operate with these types of fuels in the future. And you have these relatively small companies that are bringing this technology in. So it's really amazing. It's a fun time. Usually in the US, since we're talking US centric, the US is not a driver of technology typically, but we're kind of seeing it differently now. We are seeing some firsts. First boats of their type are being designed and built in the US because they're being driven from the short distance shipping industry. And like Jan had showed, there was 5,500 towboats and tugboats in the United States. There's probably another 1,000 ferries in the United States, which makes it a really large fleet that has the mandate, because they work in these regulated kind of coastal areas. And if anyone's calling in from California, they know the new CARB regulations that are coming out that are creating requirements for emissions that is going to then kind of drive the industry. So it's, like I said, it's exciting. I think we should always kind of reward these early adopters. I think they're doing great work. I think forums like this where we can highlight some of these projects and some of these teams. I know NETSco has done a lot in the space and should be rewarded for the effort, because it is a lot of effort. Like, and I'll close with what we started with is it's not for the faint of heart. It is a lot of hard work, and I appreciate the people on this call are typically people kind of driven for this message, working on this tirelessly every day. And I know for myself and my team and from within ABB, we're very, very excited about the future. And we're very proud to be working with a community that really values the next generation of design to be more sustainable and improve safety and keep the maritime industry as a leading indicator of profitable growth for GDPs is important. So I think I will close it out and kick it back over to you, Sofia. And look forward to some Q&A. Hopefully I get left enough time.
Thank you so much, Ed. That was very interesting. I'm bursting with questions. I've been sitting here with my hot seat for a long time now, and we have two very talkative participants today. So we will have to spend our time wisely. I invite all of you to share your questions in the Q&A tab, and I will try to pick up on those as they come along. But when we spoke first time with Jan and Ed, I raised the question about why should we have ammonia propulsion on these smaller inland vessels and not look at maybe battery electric propulsion? Because when we look at the development of maritime ammonia, it is primarily happening on the larger vessels. So you had a very good answer to that when we spoke last time.
Yeah, I mean, it's basically driven by the range. So the battery technology is very efficient, and it has it goes back to energy density, right? So the energy density is basically the problem. We did some studies of what's called fleet tugs, which they go to and from the vessel, right? And I'm sorry, to and from the towboat fleet, and they go back to the dock. And there's some advantages to go with batteries. But once you cross that 1 hour, 2 hour threshold, then you need another fuel. And as Ed said, it'll be a combination of both, right? So one of the things why we push electrification is because of that, because you can optimize your operating the design to your operating profile so that you can benefit from battery power where it needs it, and then use your internal combustion engine, or in this case fuel cell, wisely. So but that's primarily it. So you need a little bit more energy density.
Thank you. Looking at this particular part of the world with the Mississippi River and all the production that is happening on ammonia and the use of ammonia, it looks like the perfect case, the perfect synergy for exploring ammonia as a maritime fuel. I think this is what you also agreed upon, that's really the case. And so my question would then be, what are now the ingredients necessary to unlock this synergetic potential? You touched upon the regulations, and that is one part. But can you explore a little bit further what is really needed now to move forward and unlocking this obvious synergy?
Okay, you want me to take it? Or
No, please. No, go ahead, Jan. This is,
Yeah, so I like to use the model of the Viking Energy in Norway, because that's there was some industry, but also some funding, some government funding to start the study. So right now, because there is no regulation driving it, I mean, the inland waterway transportation is a business, so they need to be sustainable and they need to be financially sustainable. And it's very difficult for an owner to take on a pilot project that is not going to be cost effective. Yes, going down the line is going to help the industry adopt this. So bearing some regulatory mandate, there has to be some incentive from I would say the government, so that it can allow some of these technologies to be tested and to be proven, so that then we can start installing them. Because as I said before, is the truth is, when you compare one to the other, yeah, you're going to be disappointed, because a diesel towboat is very simple to operate, right? And this ammonia per se, which again, it's a carbon free, not only carbon free, ultimately it's going to be a renewable generated fuel, right? So it's going to make from renewables, so it'll be carbon free from all ends, right? So it's very positive on that way, but it requires some testing. It requires some storing it. You have to either pressurize it, or you have to lower and liquefy it, which requires some.
Jan, in this region now, is there visible development on green ammonia plants being developed? Because operating on conventional ammonia is not giving us that carbon benefit. So could you share anything on that?
Yes, there is. So there's several developments. So the first one is the blue ammonia development from CF, and I don't know if there's somebody from CF in the audience that could help with that. But as I understand, is next year there will be the blue ammonia facility in Donaldsonville will be ready, and as I understanding, that facility would also have future plans to turn it into a green ammonia facility. That means power has to come in from some sort of renewable. They'll have obviously electrolyzer powered by some sort of renewables. And then there is another facility that has been now announced for 2024, I believe it is, and it's in Iowa, if I remember right. Those are the I'm sorry, but those are the two facilities that I'm aware of. Yeah. And I also understand Yara is looking into another green ammonia facility in the waterways as well.
And here, of course, we can market a little bit the work that the AEA is doing on mapping renewable and low carbon ammonia plants being developed around the world. So a little hint to that. For this particular ship project, this towboat, we didn't spend too much time on it, but I would like to ask the question, when we look at the kind of the US marine transportation segment in general, could you share anything regarding what would be the best ship cases to trial ammonia as a fuel and qualify technology, and piloting ammonia to build demand and scale? Those may not be the two same ship types. Would you have any reflections on that?
I'll let you
I can make a first comment and then you can continue. So yeah, first, it looks like the early adopters will be ones that obviously have the fuel available locally. So obviously this transportation on the inland side is where they're moving product. So probably first adopters will be someone who's in that trade, someone who's working with ammonia production facilities or consumers of ammonia already. They really lend themselves to, they're in that trade. They can possibly get a premium because, again, it's providing the service of a ton mile moved of product, And someone who's in that industry of ammonia will see more value in saying, hey, if I can get a complete supply chain of ammonia in my transportation, that's going to be these what we see as probably the first adopters, and that goes also for, you know, petrochemical, you know, if it's a methanol producing facility or something like that, or CNG, they like to use their fuels that they have available, that they can promote. So that's, and they have the knowledge typically of the product, they have the product available, and they have the ability to get a premium for that service is typically first adopters. And then once it's done and proven, then yes, the maritime industry is very much a industry of, I've seen someone else do it, so now I will try it.
I will take a question from the floor here. We have one from Mr. Rodrigo Rivera Menen, I think. So he asks, for the creation of this new ecosystem based on ammonia, what is the consumption expectation? And if you think of a charging circuit for this new fuel, will gray ammonia be used initially, or will PEM be explored for green ammonia? Would that be a question for you, Edward?
Not really I mean, I could just comment on what we're hearing, but we're not actually involved in the ammonia production or ammonia supply side of things. But we definitely see, on these alternative fuels, gray seems to be the starting point because that's what's available, and it's already produced. And so it makes sense that that's the starting point with the eventual goal of getting to a green source. Is really always kind of the trend that we're seeing, that we're using kind of byproduct fuels to begin, and then eventually the goal is to transition to green sources for these alternative fuels. Again, getting away from that argument of just, you know, that well to wake. There may not be a perfect solution to well to wake in day one, but certainly that's the goal in the transition.
Yes. We had a question here from Muhammad Aftab, who is asking if whether someone is using ammonia as a fuel as of yet, or if we are still working on the technology. And there may be several of you out there who also have that question. And the first internal combustion engines will be made, are expected to be available in the market by 2024. So what we will see in the next year or so are trials taking place and the maturing of technologies. But what we do see are growing numbers of orders for ammonia-ready new builds. So there is obviously great expectations in the industry that this will be available technology.
Sofia, real quick on the just on Rodrigo's question, the second part of the question, I think just want to cover something that's important, because this is we are studying this a lot, and that is the trade-off between a PEM, which is a hydrogen, the makeup of this fuel cell. It can only use hydrogen, and having ammonia as the hydrogen carrier, and then cracking it and using a PEM. Obviously, the PEM is the most efficient fuel cell, is in the order of 80%. A solid oxide fuel cell, which is being tested to burn ammonia directly, is 60%. So there is half dozen on one hand, half dozen on the other. Both will work. I think it's going to get into the development of the cracking of hydrogen. That technology is moving pretty quickly. So if that moves quicker, then it's always easier to, I mean, the PEMs are further developed than the solid oxide fuel cells. So that would be, that would probably be the preferred method if the cracking technology gets ahead. If not, then the ammonia burning solid oxide fuel cell, which is being tested now on the Viking Energy, could be a potential. Right?
We have Christian Hermle here asking if either of you think that the combustion engine will be substituted completely by fuel cell in the future. What would you say to that?
My personal opinion is Yes, I think, I mean, I would like it that way. It's a much more efficient motor of engine. I mean, internal combustion engines, except for hydrogen, yes, they're not efficient. So, you know, you have an engine that's already 30%, you know, with 35–40% efficiency. Now you're adding a less efficient fuel than, which is, you know, in the case of ammonia we're talking about here. Yeah, you have, I would say yes. I would see, let me just say yes. That would be my
We have only a few more minutes to go before we have to round up, but we received some questions regarding environmental impact and safety related concerns. And so back to you, Ed. Would you have anything to share with how ABB is looking into any monitoring systems of ammonia emissions and or so on?
Yes. So of course, I think the one nice thing about the maritime industry is we are used to these products because they're usually typical product. So the maritime industry is used to handling hazardous cargoes and using this, just not utilizing it as a fuel on board. It definitely changes things a lot. And there's a lot more regulation around utilizing something as a fuel versus just carrying it from point A to point B. But it gives a starting point. So there's already a healthy amount of maritime systems that do monitoring, that can control, you know, from the LNG side of the business. It's already been established. So yeah, ABB and a lot of companies are involved in monitoring and keeping safety, because that's the first thing as we're going through these fuel sources, different alternative fuel sources like ammonia. It's introducing some challenges and some safety issues, and the first thing is to conquer that. Like, we realize, yes, the downstream is we want to get this renewable source of energy, but really we can't do anything that won't be safe, for the immediate, but also for the long term. It's very important that these first projects are very safe and result in more projects. We cannot afford to have a project that goes badly, that hurts people, and then also sets back technology for a long period of time. So yeah, we take the safety and monitoring very important as part of this installation and design.
Thank you, Ed. I just decided that those were your closing remarks, and I will allow Jan to round up our session here. Jan, what would you like the audience to bring with them from today?
Yeah, so in that would help answer some of the other questions. So there is no one fuel fits all purposes. Ed mentioned the benefits of carrying the cargo that you're going to be using as a fuel. That's how LNG started. But for the most part, I think it's important to understand that we're not comparing one with the other, because the one with, you know, you're always going to lose against diesel. It's a very efficient fuel. But if we have to, not said if, but we have to obviously reduce greenhouse gases emissions, and ammonia is a good alternative. Is widely traded already. It's the safety concerns that have been voiced are actually dealt with on a day-to-day basis with ammonia as cargo, and it could be generated from a renewable source. So it does require more technology, more investigation, but I think it's worthwhile.
Thank you so much, Jan, and thank you to you, Edward, as well. It's been a great pleasure to having you both here for this late afternoon session for me and for your morning session for you. And thank you to Julian back end over there in Melbourne. And to all of you who are about to hang up, please join us on August 17th, where we will meet MAN Energy Solutions and Maritime Port Authority of Singapore, who will focus on key engine development projects currently taking place. So over and out from the Ammonia Energy Association. Thank you.
Thank you.
Cheers, everybody.